We can perform operations with functions like adding, subtracting, multiplying, and dividing. You've done all these things before, but there's some new notation that we need to look at. So we're looking at how to do these operations with a graph, a table of values, or a set of points, or an equation. So all of these different ways the function can be represented. So let's start with a graph. If I asked you to find f plus g at 2, if this is f at x and this is g at x, what they want you to do there is just to find f at 2, so the y value at x equals 2, and add it to the g value at x equals 2. So let's go over to our graph, to an x value of 2, and we'll trace up to f at x first. The y value is 2, and then we'll continue up to the red graph, which is g at x, and the y value is 4 at x equals 2. So our answer is going to be 2 plus 4, which is 6. We can also subtract the same way. We can multiply. So if we want to do f times g at 0, both of these graphs cross through 0, 0. So we simply are going to do 0 times 0, which is 0. So just multiply the y coordinates. If I wanted to subtract f minus g, or let's do it the other way around, g minus f at negative 2, we're going to go to x equals negative 2. We're going to trace up to g first, or down to g first, which is the red graph. And our y value is negative 4. So g at negative 2 is negative 4. And then we are going to subtract f at negative 2, which is the blue graph. So we're going to go up here, and its y value is 2. So f at negative 2 is 2, and negative 4 minus 2 equals negative 6 is my final answer. Notice that wouldn't be the same as f minus g at negative 2, because then I would start with f at negative 2 and subtract g at negative 2. So for adding it wouldn't matter, but for subtracting the order matters, because f at negative 2 is 2, and g at negative 2 is negative 4. So that would give me the opposite sign, positive 6, which maybe you could have predicted. Okay, so now we're going to look at a set of points. So I could have this organized in a table or just as a set of points. So f at x is just the 4 points, negative 1, 5, 2, 0, 3, 1, and 5, 8. And g at x is negative 1, negative 5, 3, 0, and 5, 0. So we want to start with doing f plus g at x. You could write it as f plus g at x, or you might also just see it as f plus g. Either way works. Okay, so what you're going to do is you're going to look at the x coordinates that line up. So when f is negative 1 and g is at x equals, when f at x, when you look at x equals negative 1, you do have a y coordinate of 5, it's defined, and for g to x, when you look at an x coordinate of negative 1, you have a y coordinate of negative 5. So we keep the x coordinate the same, just like we did with the graph. We just went over to x equals negative 1, and we just added the y coordinates. 5 plus negative 5 is 0. So negative 1, 0 is my first point on the graph f plus g. Now I look at a value of x of 2 at for f at x, and it has a y value, or f at x value, of 0. So f at 2 is 0. But unfortunately, if you look through g, there are no points that have an x coordinate of 2. So that one I cannot add. So there has to be that overlap in the domain. It has to have the same x value in order to add, subtract, multiply the y value. The next one, though, I think works. So if we go to x equals 3, the f value, f at 3 is 1, and g at 3 is 0. So I can add 1 plus 0, so I get 3, 1 as my next point. And finally, 5 should also work, because you'll see that there's x equals 5 in both sets of points. So I'm going to just add 8 plus 0. So it's going to be 5, 8. Okay, I can also subtract. I can multiply. So let's try a multiplication one. F times g. And again, it could say f times g at x, or just fg is the other way you'll see multiplication. So you're going to do the same thing, except for now you're going to multiply the y coordinates. So at -1, we have 5 times -5. So that gives me -25. Again, at x equals 2, f at x has a y value, but g at x doesn't. So I'm going to skip ahead to when x equals 3, and 1 times 0 is just 0. So 3, 0. And finally, when x equals 5, 8 times 0 is also 0. So that's how you deal with a set of points. It could also be organized in a table the same way. Okay, so we also can be given an equation. If we're given an equation like -2x, hopefully we can recognize this as just a line. And f at x equals x squared is just our basic concave up parabola. Okay, so when you multiply them together, you should expect to increase the degree, because you're going to be multiplying x squared by x, and you have to think of your exponent rules. So you'll notice here the notation, this means multiply. I never use a dot, because that's going to get confusing when we talk about composition. So you'll either see f of g written that way or f times g. So we want to multiply. So this means f times g at x is equal to f at x times g at x. F at x is just x squared when I substitute in the equation, and g at x is -2x. So multiplying together, we end up getting -2x cubed. Okay, so now let's say f at x is x plus 1. Again, that one's just a line. And g at x is a cubic. So when you're adding, your highest power should be the highest power in the question. So x cubed will be the highest power. When you're multiplying, you're expecting an x to the 4th. So if I add f at x plus g at x, I would get x minus 1 plus x cubed, and I can just rearrange that from highest power to lowest. So you do have a cubic as your final answer. F times g, so x minus 1 times, so f at x is x minus 1 times g at x was x cubed, and you'll end up with x to the 4th minus x cubed. And I think that's it. So we're all done. Next time we'll look at composition.